Welcome back to Rewired Logic. In the previous videos, I've taken 3 pilot valves, pulled them apart, inspected them, cleaned them, lubricated them, and put them back together again. What we're going to do in this video is test them. As you can see, I've taken a loop calibrator, hooked it up to the positioner, and put 4 milliamps on it. That is a 0% signal. Now this positioner that I've got set up here is a test setup that I've put together so that I can test these pilot valves. If you look closely as well, you'll see that I've got a black wire connected to the white wire and vice versa. The reason for that is because inside the positioner, this is standard. That means that the negative wire is the white one and the positive one. When I turn on the supply air, I'm going to expect this positioner to stay at 0% in the closed position, unless there's something wrong. A quick play with the counterweight that's connected to the leaf spring shows me that this pilot valve does not want to move. It is stuck. To fix this problem, I'm going to remove completely the automatic manual changeover screw. The automatic manual changeover screw has a big hole on the side at the bottom that goes all the way through. At the bottom of the screw is a very tiny hole that connects to that. To clean out this automatic manual screw, we're going to need something very small to fit into that small hole. The best thing I found to use is stranded wire, and using only one strand will fit in there. 2 strands definitely won't fit, and if the strands are too big, it also won't fit. So try and find yourself a bit of wire, stranded wire, so that you can clean out this little chamber. You'll be able to see that you're getting it cleaned out because you'll be able to see the wire through the bigger hole on the side of the screw. With the automatic manual screw cleaned out and put back into the pilot valve, I can now continue the testing. When I turn the air back on, I'm going to expect this positioner to swing back to the 0 position for the 4 milliamp signal, as it should have been in the first place. Now I am able to toggle the counterweight to make the positioner move, to force it open and shut. This means that the pilot valve is working well. What this also means is at this point you can probably turn everything off and take the pilot valve out, because we've tested it, and if we can test it mechanically, it's all we need to do. The 4 to 20 milliamp signal has nothing to do directly with this pilot valve. So once we've mechanically tested this pilot valve by toggling, that's all we really need to do. But what I'm going to do later is maybe show you how to set it up if you are changing out a pilot valve in the field, how to set the 0 and maybe even the span. But for the sake of testing pilot valves, this is as far as you really need to go. In this part of the video, I've taken the second pilot valve and put it into the positioner, and we will test it to see what happens. As you can see, this one has the same problem as the first pilot valve. It swings open immediately. We know how to fix that now. For reference, when you're changing out a pilot valve in the field, you should always zero it. A small tip when you are doing this with a standard setup, if you turn the wheel in one direction, the cam will follow that same direction. So if we're going up with the zero screw, we are going up with the cam. If we are pushing the zero screw down, the cam will move down. Now I'm going to test the third and final pilot valve that we have overhauled. Hopefully this one goes better. Thank you for watching Rewired Logic. Please leave a like, please subscribe, and even leave a comment, especially if you want to see something really specific or you have a question. Thank you for watching the 3-part series on how to overhaul pilot valve.